Good morning, everyone. I am Sumit Kumar Singh. I am going to deliver my presentation on clustering and social graph. Clustering means combining similar items together, and social graph is just a way to show people and their connection. Or we can also say that social graph is a network of people and connected by relationship. This presentation explores how graph clustering techniques are used to identify meaningful communities, detect hidden patterns, and extract valuable insight from complex social network data. What is a social graph? A social graph is a fundamental structure in network science that models how entity connect. It represents entities, user, post, organization, edge nodes, and their relationship, friendship flow, likes, replies, interaction, edge. The sheer scale of this graph is massive. For example, platforms like Facebook and LinkedIn connect millions of nodes, enabling dynamic information flow and formation of communities. Understanding the topology of this graph is the first step towards extracting social intelligence. Why cluster? Why cluster social graph? Clustering is the process of partitioning the graph into groups where the connection within the groups are dense and connection between groups are sparse. This reveals the intrinsic community structure. Now let's move to the subtopics of the cluster social graph. Identify communities. Discover natural grouping like friends, circle, interest based forums, or professional network that share common traits or frequent interaction. Next, reveal influence structures. Pinpoint influential communities and key bridge nodes that connect disparate groups, crucial for diffusion models and targeted outreach. Enhance data analysis, reduce the complexity of the entire graph by focusing analysis on a specific, smaller, coherent cluster, improving efficiency and insight extraction. Clustering transform a massive, undifferentiated network into a structured landscape of meaningful social unit. Key clustering algorithm for social graph. Choosing the correct method is critical as different algorithms are optimized for varying graph characteristics such as size, density, and desired cluster output. K means clustering. Partitioning partitions nodes into a predefined number k of cluster based on the distance or similarity. It is a fast and efficient for dense graph but require prior knowledge of the optimal k. Binary space partitioning (BSP) or top-down recursive methods that efficiently splits the data space using hyperplane, highly effective for scaling to extremely large social network due to its hierarchical nature. Communities detection method algorithm like Lowen or Wartrep especially optimized for modularities, a measure of the strength of the community division. They automatically find natural cluster without needing a preset number. Case study binary space partitioning (BSP). BSP stand out for its high performance when dealing with the colossal scale of modern social media graphs, where other methods become computationally prohibited. How BSP work? It begins with the entire networks and recursively apply a split, effectively dividing the graphs into two parts at each step. This creates a hierarchical structure, making it possible to analyze communities at different level of granularity. The efficiency of the recursive splitting allows for rapid processing of dense, high-dimensional social media. BSP speed and adaptability make it favorable for platforms like Twitter or LinkedIn, where real time analysis of network dynamics is essential. Real world application of social graph clustering. Clustering is not just a theoretical concept, it drives critical business and security function across various industries. Targeted marketing. Brands identify a small, highly engaged influencer groups, micro communities on platforms like Instagram to launch highly effective niche advertising campaigns, security and fraud detection, anonymous clustering patterns such as a dense group of users with identical non-human interaction pattern can quickly expose fraudulent account or botnets. Recommendation system. Clustering user with similar viewing or purchasing history. Example, Netflix, Amazon allow platforms to provide highly personalized and accurate content suggestion. Public health tracking. Researcher cluster contact networks to model disease transmission and understand how behaviors within communities affect pathogens spread and mitigation effort. Challenges in social graph clustering. While powerful, clustering large real-world social graph presents several significant technical and conceptual hurdles. Algorithm selection. The optimal algorithm depends heavily on the network's specific characteristics. Example, directed versus unidirected edge network size. A poor choice can yield meaningless result. Dynamic graph. Social relationships constantly changes. Maintaining cluster accuracy require computationally expensive, frequent reclustering to keep up with the graph's evolution. Overlapping clusters. Real people often belongs to multiple communities, work, family, hobby groups. A standard clustering model struggle to assign a node to more than one group accurately. Efficiency versus accuracy. Massive graphs demand scalable algorithm, often forcing a trade-off where computational speed is prioritized over the nuisance of the clustering result. Visualizing cluster from data to insight. Effective visualization is crucial for interpreting cluster results, transforming complex mathematical partitions into actionable social insights. Graph visualization tool like Gephi or Saito escape render nodes and edge, allowing analysts to interactively explore the network. Clusters are often visually distinguished by color or spatial proximity, immediately highlighting the discovered communities. Identify bridge nodes. Nodes connecting two or more clusters is vital for understanding information flow and cross community influence. A visual comparison of the raw messy graph versus the clustered organized graph provide a powerful narrative of discovered social structure. Future of clustering in social graph. Future developments in clustering will focus on adaptability, security, and integrity with advanced machine learning techniques to handle increasingly complex data stream. AI enhanced adaptability, integrating clustering with deep learning and reinforcement learning allow for adaptive real-time communities detection and continuously streaming social data. Misinformation detection. Enhanced clustering techniques will better identify coordinated in authentic behavior and influence campaigns by detecting tightly organized rapid growth cluster. Privacy preserve method. Developing developing Met- Developing methods to cluster social network without compromising user data crucial for decentralized and privacy focused program. Conclusion: unlocking social insights through clustering. Clustering is an indispensable technique that transform the daunting complexity of the social graph into understandable, actionable knowledge, strategic advantages. It provides businesses, researchers, and policymakers with the necessary tools to understand the and influence the underlying dynamics of the social interaction. Navigating complexity as social media networks continue to grow and diversity, clustering remain the most vital tools to navigate and harness their immense potential. Embrace graph clustering to reveal the hidden communities shaping our connection world.